Today we're going to talk about Chapter 9, Section 6, which is solving a right triangle. To solve a right triangle, all right triangles, we have to know, first of all, have one right angle, that's why we call it a right triangle, two acute angles, one hypotenuse, and if you'll remember, the hypotenuse is opposite or across from your right angle, and then two legs, the sides that form your right angle. To solve a right triangle, you have to find the measure of each of these parts. So to solve a right triangle, we're going to have 6 different answers if you're including the right angle. If you know the sine, cosine, or tangent of an acute angle, you can use a calculator to find the measure of the angle. We're going to do this using what we call inverse sines. If the sine of A equals x, then the sine, and if you see the little -1 as your exponent, that is read as the inverse sine of x, will give you the measure of angle A. If you have a calculator, usually you have to click a shift or a mode or a second button, and then click the sine button, and then instead of doing sine, it will do the inverse sine. We've talked about sine, cosine, and tangent the last couple of days, so today we're going to use the inverse sine. Remember, we used just sine, cosine, and tangent to help us find the lengths of the sides. Now we're going to use inverse sine, inverse cosine, and inverse tangent to be able to find the angle measures. On your calculator, I would like you to try to do the following. And you should notice a pattern. If you don't notice a pattern, then we need to talk. If you just follow the instructions, though, you can go ahead and pause this video and then restart after you've experimented with your calculator. Okay, I hope your calculator worked out for you. What happened? If you chose your own acute angle, it has to be less than 90 degrees, and see if that pattern keeps working. Then try an obtuse angle. Try something greater than 90. And does that one work? You should notice something. Again, pause this video, try it on your own calculator, and see what happens. Let's go ahead and try to solve the right triangle. Go for it. It says to round their decimals to the nearest tenth. That's going to be important for my answer. If you notice, we know both legs. One leg is 8 and one leg is 10. We're going to go back to the Pythagorean Theorem to find b, or the length of my hypotenuse. So plug it in. We have we have 8 squared plus 10 squared equals b squared. Go ahead and square them. 8 squared is 64, 10 squared is 100, equals b squared. Add them up, you get 64 plus 100 is 164. Remember to get rid of your b squared, we just want a b, so we take the square root of both sides. The square root of 164 is not a perfect square. We are just going to simplify, plug it into our calculator, round it to the nearest tenth, and we know that our hypotenuse is about 12.8. We know that the tangent, to find angle A, we know that the tangent is our opposite over our adjacent. So we said tangent of A equals 10 over 8. Go ahead and divide 10 over 8. So say tangent of A equals 1.25. Now we know the tangent is 1.25, so we can take the inverse tangent of 1.25. Go ahead and click second tangent and then plug in 1.25. If you have a calculator, sometimes you have to do 1.25 and then click second tangent. Either way, make sure you're in degrees, and you should get 51.3 degrees. Now that we know two angle measures, we can use the third angles theorem. So we know our 90-degree angle, plus we just found the 51.3 degree angle, and we know that our third angle should make those two add up to 180. Go ahead and subtract 141.3 from both sides, and you wind up with 38.7 for your angle C measure. Let's try solving another right triangle. If you want to try on your own, pause this and come back and check your answers. That would be an excellent way to check to see how you're doing. In this right triangle, we've been given one of the angle measures. So automatically, I know that I have the right angle at angle T, and I know that angle R is 20 degrees. I can go ahead and add those together and subtract from 180 and solve for my third angle, angle S. So the measure of angle S is going to be 70 degrees. I'm given the hypotenuse. I can use whichever one that I want to. I chose to do the sine of 20. Remember, sine is opposite over hypotenuse. So I said the sine of 20 degrees is R over 15. R is opposite of my 20-degree angle, and 15 is the hypotenuse. To get R by itself, I need to multiply by 15 on both sides. Again, if you're having problems with your calculator, that's just something that you're going to have to come see me. If you go to mode, and if you make sure that you're in degrees, that is sometimes the biggest mistake and easily fixed. And there's nothing wrong with you if it's in the wrong mode. When we plug that into our calculator, you should get 5.1. You can use the Pythagorean Theorem there, but since we've rounded, I'm not going to. I'm going to go ahead and do the sine of 70 degrees. So now I'm talking about angle S up there. I'm going to say that sine of 70 degrees is S over 15. Again, it's opposite over hypotenuse. Plug it into your calculator, 15 times the sine of 70, and you wind up with S equals 14.1. And again, I've solved, I know all 6 parts of this triangle. Let's try a little word problem for ourselves. The height, it says you are flying a flight. My little recording thing is over it. It says during a flight, a hot air balloon is observed by 2 persons standing at points A and B, as illustrated in the diagram. The angle of elevation of point A is 28 degrees. Point A is 1.8 miles from the balloon as measured along the ground. And if you noticed, I've gone ahead and I've labeled what I know. It says, what is the height h of the balloon? Well, I'm given 28 degrees as angle A, and I'm given that 1.8 is the distance from angle A to the hot air balloon on the ground. So I've gone ahead and labeled that. If you notice, h is opposite my 28 degree angle, and I know the side that is adjacent to my 28 degree angle. So I need to think, what uses opposite and adjacent? And the answer would be tangent. So to find h, I'm going to say the tangent of 28 degrees equals h over 1.8. Multiply by 1.8 on both sides to get h by itself. Plug it into your calculator and you get 0.96, and that would be miles off the ground. And then we go to B. It says point B is 2.8 miles from point A. I've gone ahead, if it's 2.8 miles from point A, it's only going to be 1 mile from the balloon. It asks you to find the angle measure of point B. So now we're looking for the angle of B, and I already have solved that h is 0.96. So I can plug it in and say the tangent of B is opposite, which is your h, which we already solved, is 0.96, over 1. Go ahead and take the inverse tangent of 0.96, and you get the measure of angle B to be 43.8 degrees. I've answered both of the questions. I'm ready to move on. Today's assignment for practice, I would love for you to look over and get started on page 570, numbers 12 through 26 even. We will answer questions in class, etc., etc. I hope you guys have a great evening, and I will see you later.